Lesson number 3, X and Y intercepts and interpreting relations. So just a quick review of things that we looked at yesterday. A relation is a connection between two quantities. And a relation can be represented graphically using what? A set of ordered pairs. The first component in an ordered pair is what? The x-coordinate, which is called the input. And the values of the input are which variable? The independent variable. Thank you, Jonathan. The second component is called what? The y-coordinate. It is the output, and the values of the output are called what variable? The dependent variable, because it depends on the input. So the output is dependent on the input. So in the next part, we're going to explore x and y intercepts. So we consider the following 3 graphs, 1, 2, and 3. What kind of a graph is graph number 1? It's a linear graph because it forms a line. So if this one is linear, we can call these two non-linear. Do you guys remember what the name was that I told you for the U-shaped one? Quadratic. And then this one would be a circle equation graph. Okay? So list the coordinates of the points where each graph crosses the x-axis. So where does graph 1 cross the x-axis? So what would be the coordinate right here? -3 and 0. So I want you to identify what those coordinates are for graph 2 and graph 3. Where does it cross the x-axis? So where does graph 2 cross the x-axis? -2 and 0 and 3 and 0. And where did graph 4 cross the x-axis? -4 and 0 and 4 and 0. What do all 5 of these points have in common? Y-coordinate equals 0. Good. Okay. So now in the next part, go back to the 3 graphs again, and we're going to identify where they cross the y-axis. So the y-axis is my vertical. Where does graph 1 cross the y-axis? 0 and 5. So I want you to do the same thing for graph 2 and for graph 3. So where does graph 2 cross the y-axis? 0 and 6. And graph number 3? 0 and -4. Thank you. What do these 4 points have in common?
Their x-coordinate equals 0.
So x-coordinate equals 0. So the x-intercept, what does it mean to intercept something? To cross paths with. So an x-intercept is a point that crosses paths with the x-axis. A y-intercept is a point that crosses paths with the y-axis. So if we notice those x-intercepts that we had found in the first part, all of the y values were equal to 0. So if I gave you an equation and I said find the x-intercept of this equation, instead of having to graph it and try to find it on there, I could let y be equal to 0 and solve for the x value. If I wanted to find a y-intercept, I would let x be equal to 0 and then find the y value for when x equals 0. One other thing is to realize that equations for graphs can be written in different forms. So this equation of the linear graph that was on the first page can be written in the form of 5/3 x plus 5. Or it could also be written as 3y equals 5x plus 15. Or it could be written as 5x minus 3y plus 15 equals 0. Over the course of the next several chapters, we will actually examine how do I go from this form to that form, and vice versa. Okay? For the time being, what we're going to do is we're going to use this instruction to determine x and y intercepts. That's what we're going to be working on in this class. So with the equation from graph 1 given to us as 3y equals 5x plus 15, we are going to algebraically determine the values of the x and the y intercept. So algebraically means we use the equation, we show our work. Graphically means we could possibly use the graphing calculator when we look at how do we graph on it, and we could use the calculator to do that for us. So with the x-intercept, we let the y value be equal to 0, because when the x-intercepts, or when the graph intercepts the x-axis, the y value will be equal to 0. So I have 3 times 0 equals 5x plus 15. So what's 3 times 0? 0. How do I get 5x by itself? So if I subtract 15 on both sides, I'm left with a 5x on the right-hand side. What do I have on the left-hand side? And how do I go from 5x's to 1x? Divide by 5, and what would x equal? So the x-intercept equals -3. Is that what the x-intercept was on the previous page? Jonathan, is that what it was? Yep. Okay, so now we look at the y-intercept. With the y-intercept, we let x equal 0. So we have 3 times y will equal 5 times 0 plus 15. Well, what's 5 times 0? 0. So I have 0 plus 15, which is just... So if 3y equals 15, what does 1y equal? 5. So the y-intercept would be equal to 5. And again, if you flip over to the previous page, you will see that it does cross the y-axis at 5. The third graph on that page is given by the equation x squared plus y squared equals 16. So we're going to calculate the x and the y-intercept of this equation. So how do I find the x-intercept again? Let y be equal to 0. So if y equals 0, I get x squared plus 0 squared equals 16. What's 0 squared? 0. So x squared equals 16. And square root 16, and what do I get? 4. Okay, flip on the previous page. What were the x-intercepts?
4 and -1.
So what happened? Did I do anything wrong? When I take the square root, remember we talked about it earlier in the year? You get a principal square root, but then you get that secondary, that negative square root. This is the circumstance where I have to put both of them in there. The positive and the negative go in there. Because if I work backwards, if x equals 4, 4 squared equals 16. Negative 4 squared also equals 16. So in probably 70-75% of the time when I take the square root of the number, it's just the positive value. This is one of those 25% times where the negative has to be considered. Because this graph gives me a circle and it crosses the x-axis at 2 places.
So you put both of the signs?
Yeah. So the x-intercept would equal +4 and -4. Or I could write it as plus minus 1 on top of the other. How do I find the y-intercept? I let x equal 0. So I get 0 squared plus y squared equals 16. So y squared equals 16. And then I take the square root of both sides. And what would I get? I would get a positive and -4. So the y-intercept would equal positive and -4. And again, if you look back on that graph, there were 2 y-intercepts at +4 and at -4. So I'm going to give you about 5 or 7 minutes. I want you to do question number 3. And then we'll do the next part. So Lisa purchases a new car for $20,000. The value of the car can be represented using a formula V equals 20,000 minus 1250T, where V is the value of the car in dollars and T is the age of the car in years. So we're going to complete the table of values and then we're going to plot these pairs on a grid. So at 0 years, so when the car is 0 years old, what's the value of the car? $20,000. So then my ordered pair would be 0 and 20,000. So I'm going to give you a couple of minutes. I want you to determine what the value of the car is after 2, 4, and 6 years. So if I have an input of 2 years, how much is the car worth?
70,500.
So then my ordered pair would be 2 and 17,500. What is the car worth after 4 years?
15,000.
15,000. And after 6 years? So if I graph these, plot these on the grid, at 0 years I'm at 20,000. And then I just need to see my scale. So after 2 years I'm at 17,500. 4 years I am at 15,000. And at 6 years I'm at 12,500. And then you're asked to connect the points with a straight line and to extend the line. So if I connect these points with a straight line, and if I extend that line, so you would need to use a ruler that's long enough that would allow you to do that. Who needs a ruler? Coral. So what does the ordered pair 0 and 20,000 represent? It's what the car cost when it was brand spanking new.
Well, what car is it? Because sometimes I'm going to drop that fast.
Pardon me?
If you get the
It's
car,
a big
it
bothers me.
What bothers
The
you?
guy was
We'll get to that point. Use the graph to determine the t-intercept. The t-intercept being where it crosses the t-axis. Which of the two axes is the t-axis? The x. So where does this cross the x-axis, or in this case the t-axis? So 16 and 0. What does this represent? So how long for the value to equal 0? So after 16 years, in theory, the car would be worth nothing. Okay, so let's use the graph. Tell me how much the car is worth after 3 years. 16,000, because I can go over to 3, go up to where I intersect the graph, and then read over. So 16,000. What about after 10 years? 7,500? And after 14 years? 2,500. So question E says to verify these with the formula. I'll let you do that on your own.
You only have to verify the 10 years.
Oh, the 10-year one. So let's verify the 10-year one. So this was V equals 20,000 minus 1,250 times 10. So that would be $20,000 minus 12,500, which does equal 7,500. So in question F, we go the other way. Tell me how long it'll take for the car to be worth $5,000.
12 years.
So I go from 5 to the line, follow it down, 12 years. And when is the car worth half the purchase price?
8 years.
8 years. So half the purchase price is 10,000. Follow it down. I get 8 years. So if I use the formula to verify this, the value of the car is 10,000 equals 20,000 minus 1,250 times t. How would I get t by itself? Before I divide.
Subtract 20,000.
Subtract the 20,000 on each side. So I would get negative 10,000 equals negative 1,250. Right? And what is, so then I would divide. T would equal negative 10,000 divided by negative 1,250, which would equal 8. So let's fill in the following statement. The original value of the car is $20,000. It depreciates in value by how much per year? 1,250, and has no value after 16 years. In theory. In practicality, that's not necessarily the truth because you can always sell it for something. Although I've been trying to sell a car for something and I haven't been successful yet.
Really, we sold it.
Yeah.
In this lesson, if I use algebra, if I use the equations, I will always get the exact value of the x and the y-intercept. If I use the graph, sometimes we might get an estimate. In this previous graph, had I not used a ruler, if my line was not straight, I might not have actually gotten 8 years. Or if the numbers had been not as nice as they were, and this line had been partway between 8 and 9, it would have been very difficult for me to state for certain if the car was worth half of its value after 8 years, after 9 years, or was it 8.3 years. The algebraic method would let me pinpoint it to an exact. Then we have the second part when we were asked to find values within this information. So when I'm asked to find out points that lie between the ones that I was given, so find the value of the car after 3 years, or in this case I could say what would be the value of the car, or sorry, how long would it take for the car to get to $16,000? That's called interpolation. You're taking it between the two values, and inter does mean in between. The stuff that we found all down here is referred to as extrapolation, because we had to extend the graph using this pattern. So because these 4 points made it look like it was following a straight line, we make the assumption, and given the equation, that it'll continue to depreciate by that amount each year. So your questions to add is question number 4, and then 7 to 9.